But first, we're going to talk about probably one of the most talked about technologies at the moment. Consumers and businesses are increasingly now truly waking up to the potential value and impact of AI. To what extent can it transform the financial services sector, and how do we mitigate risks around its use? We're going to hear now from someone pioneering its use, Jonas Andrulis, who is the CEO and founder of Aleph Alpha, and the company is on a mission to transform human-machine interactions, researching, developing, and deploying large language models and running the fastest European commercial AI cluster. So please welcome Jonas.
All right. Thanks for joining. I'm going to show you a little bit of the stuff that you haven't seen 1,000 times already in social media. This is not that. This is kind of what you already know. We're in the middle of an industrial revolution. Typically, industrial revolutions have this kind of J curve. And you can ask yourself on what part of the J we currently are. Certainly, speed has picked up quite a bit over the last weeks. And there's kind of one study I quite like that is estimating that by 2030, about half of what we today call work can be done by AI. So I think that's, we can debate whether that's 2030 or 2035, but certainly a lot of today's knowledge work will be transformed by AI and will look very different. These are benchmarks. I'm going to just mention something quickly. This is comparing our technology with some other technologies. When you look at benchmarks, you always have to keep in mind that benchmarks are measured on standard questions, and those standard questions are most likely far less complex than what you are doing. There are kind of some benchmarks that are basically asking questions like when were the Spice Girls founded, and then measuring whether the model can give the right answer. That is not a bad thing to do, but it is not necessarily the fact that a model that scores better on benchmarks will be the better choice for you. The kind of benchmarks in the middle is a set of standard benchmarks collected by us, and on the right-hand side you see the Helm benchmark run by Stanford, where we are outperforming GPT-3 with a much smaller model on those question-answer benchmarks. Eventually, yeah, we're super proud of that, but if you want to evaluate a model for your use case, you have to do a use case-specific evaluation. So you've been hearing a lot about sizes of model, and I have one example here to show you what that actually means. And we have multi-modality that it's getting a lot of press for GPT-4. We have that in production for 2 years ago, and since 2 years ago, and when you ask our model, and you show this image and ask our model if this cat were elected, its first order of business would be 2, and you ask our smallest model, it says, make sure the economy is strong, which I think is a fine answer for that question. But when you ask our bigger model, it says, declare war on the dog. So the bigger the model, the more it can read between the lines and get a feeling for context, and is something humorous, is it ironic? Our biggest model is twice the size of GPT-3. Nobody really knows what GPT-4 size is, but it's supposedly much bigger than GPT-3. All right, so let's look at the truth, right? Because it's all cool to write your homework with ChatGPT, but we want to use that for those critical high-value use cases, and that's not as straightforward. So here, if we're asking ChatGPT on what continent the assassin of Lincoln was during the time of assassination, ChatGPT knows that the assassin was John Wilkes Booth and it was at the Ford's Theater, but then tells us that it has no idea on what continent the assassin was. Why is that? No human would have made that mistake, and that is because these systems are not reasoning in the same way that humans are reasoning. They are learning patterns, and it's absolutely remarkable what kind of output we can get out of these models by just training stochastic parrots, just having them learn pattern in language. But we should never forget that This is a mistake that no thinking human would have made, and so we'll have many of those mistakes. This is another example where I'm asking ChatGPT about my role at Apple. I was at Apple AI R&D Special Projects Group, and it's basically telling me a lot of correct things about what Special Projects Group does, but it also tells us something that's incorrect, that I was a senior software engineer. I wasn't, I was leadership. So basically, interesting, right? And then I was Googling that to check whether this information is somewhere in the web, like senior software engineer, my name and Apple, it's not on there. So it's not even something that is incorrect in its training data, it is something that is never once in the web, but it's plausible, right? Because in Special Projects Group at Apple, there are tons of software engineers. So, and that's one of the big risks, is that all the wrong things that are coming out of those models, they will always be plausible. So they will, at first glance, they will always look at, yeah, this sounds right. And this is actually like a big risk. So let's look at what we can actually do to mitigate that risk. And I'm gonna zoom in here in a second. This is our test interface, so it's not how the end user interface will look like, but what we're doing here is we take an article from Sifted about us as Aleph Alpha, and we're asking a question: in what city are the headquarters of Aleph Alpha? And we get an answer: Heidelberg, Germany. And what we can now do is we can, in this article as a knowledge base, as a source of truth, we can analyze this and see, is there proof for that claim? Is there something in my knowledge base, here consisting of just one article, that proves this claim? And indeed, we see the sentence, German startup located in the picturesque German city Heidelberg, as a proof. And you might say now, okay, matching Heidelberg with Heidelberg, I don't really need powerful AI to do that. That's pretty straightforward. But there's another mention of Heidelberg in this article as our customer, because we're also working with the city of Heidelberg, with the government there, which is not highlighted. So in fact, it's not a match by word, it's a match by meaning. We can now point every factual claim to a source in our knowledge base. But we can do even more. Now let's put in an incorrect information, Berlin. Now you see basically we get a negative impact on the same sentence. So our system tells us that we have conflicting information in our knowledge base, right? So some factual information in that document is in conflict with the information that our headquarters is in Berlin. And if I ask a question like this one, what's the German capital? The answer I get is Berlin, of course. And none of the words in this document are highlighted. So what that means is, in this knowledge base is neither confirming nor conflicting information about the fact that Berlin is the capital of Germany. And this allows the user to see in my enterprise knowledge base, where's the proof, where's conflicting information, or is this information that is neither confirmed nor conflicted, and then it could be hallucination. It could also be common knowledge, like in this case. This is not wrong, but it's not something that I can add context to. So I cannot help the human expert to get the context and take responsibility in that case. And because we invented multi-modality, this works in full multi-modality. Here, asking our model to describe this image, you get a beautiful sunset over a city, and the proof is for sunset is this part of the image, and the proof for city is this part of the image. And so that's still fun, right? But think about your knowledge base. It contains tons of documents, and they all have images and texts. And now you can point to confirming or conflicting information for every claim inside your knowledge base. And this is really what's essential to take responsibility for critical use cases beyond doing your homework. Here's a test that we kind of showed at a World AI Festival in Cannes. That's like a test environment. So on the right-hand side, you got our kind of chat agent, conversational agent, and now I can ask questions like, what's the environmental policy of Germany? And then on the left-hand side, you see like there's 100 of documents that are attached. And now one of the, like they're all kind of scored, and one of them is selected. And in this document, I'm scrolling down, now we have one paragraph that's highlighted because this contains the information that has been used to answer that question. Contains the environmental policy of Germany. So we can now link everything that has been created to its source and can even persist this as an auditable information trail. So we can always go back and say, this information that we had generated 2 months ago, what was the source of that? Based on what information has this been created, and have there been some conflicting information during this creation? And I can also filter, so basically what I also did, if you're paying attention, is filtering on French documents and ask a follow-up question, and then only French documents have been selected. Here you see there's a small paragraph in French, and the model was able, because it speaks 5 languages, our AI model, to read this paragraph in French and answer the information, use the information in English. What can you do with that? This is another kind of test environment where I'm using a more complex knowledge base. What I'm doing here is I'm using the Formula 1 sporting regulations. And if there are some Formula 1 fans here, you maybe know that's like 100 pages of a pretty dry document. It contains all kinds of information and rules about Formula 1. And now I'm asking, how's the distance in Monaco figured out? And I get 2 answers that are both kind of equally correct. One is somewhat better, right? Because the second one says, by the number of laps, fine, right? But the correct one, or the better one, is the least number of complete laps which exceed a distance of 260 kilometers. And then plus the source where this is coming from. And of course, I can do the same in a conversation. I mean, you've all kind of seen these conversational agents. But now I basically have the information that is not limited to common knowledge that has been in the training data from any model like ChatGPT or the other models out there, but basically can be based on your own knowledge and can be linked to that. So I think that's pretty crucial, especially for the customers we're working with, which are financial, legal, and health customers, highly regulated industries that cannot send their data to the cloud, that cannot just kind of claim any information without proof. Yeah, and that's the whole idea, is that we are trying to use this technology to bring sovereignty back to the enterprise. Right? How can we give this technology, how can we make this accessible, configurable to enterprises with super complex, high-value use cases, to have them run that on-premise or in their own protected environment, and connected to their proprietary knowledge, fine-tuned on that, and add sources and evidence to all of those, all of that information. All right, that's it. Thanks a lot for your attention, and enjoy lunch.